So now that we have integers, we want to look at addition and how addition works with our integers. And we can think, again, using the number line as a way to represent our additions. So I'll put my origin here. And let's see, I'll come over, we'll do -3. And so we can look at -3 as being a starting point. We start with the first number. And if I add to it the integer 2, well, positive numbers move to the right. So I'd move to the right 2 steps, and I find myself on -1. So -3 plus 2 would be -1. I could start at, let's start at -2. Let me change colors here so these can overlap. We'll make it a bright blue. So start at -2. And I'm going to add to it -4. Now, if positive numbers are moving towards the right, then we can think about negative numbers as moving to the left. And so if I start at -2 and move to the left 4, 1, 2, 3, 4, and then that puts me on -6. And so addition with the sense of integers is we can look at the sign in front of the number telling me the direction to move. So being positive, I move to the right. This one being negative, I move to the left. Now, we can make this into a neat rule. We can, a lot of times, the things we do, the patterns we see in them, we can take that pattern and use our symbols to make it easier for us. And so what we can focus on is if, let's say I'm adding 2 numbers, adding integers, and I'll look at -3 plus -2. So I'll draw a quick number line here. I'll put my 0 here, and I'm starting at -3. 1, 2, 3. So here's -3. So I'm starting here, and I'm moving to the right 2, or I'm sorry, moving to the left because it's a negative sign. So I come over 1, 2, and I end up on -5. Well, these signs were the same. And so I could think about this as taking the absolute value of -3 and -2, which would be 3 and 2, and I get 5. Well, but my sign was negative, so my answer will be negative. Oops, let me put. And so what we can say is if the 2 numbers have the same sign, we add the absolute values, use the sign they shared with the answer. And this works in the opposite direction. If I have two positive numbers, well, the absolute values are the positive numbers, and I get 7. And so in one case, when we have a pair of numbers and add them, if the signs are the same, add the absolute values and keep the sign. So I think the example your book uses is -14 plus -9. So both are negative, so I know my answer. My answer will be negative. And so I can focus on the absolute value. And so that's 14 plus 9, which is 23. But because my answer is negative, I plop that sign on my answer and I get -23. So this is -23. Well, if two things can be the same, the other option we have is what happens when they have different signs. So if the signs are different, well, let's look at one. Let's take I'll draw my number lines here quickly. We'll take -2 and we'll add to it 3. And so I've come over 1, 2, 3. I'm at +1. Well, what did we do? Well, if we look at the absolute values of this, the absolute value 3 minus the absolute value of 2 equals 1. And I took the absolute values and I subtracted I subtracted from the bigger absolute value the smaller. And now we just have to worry about the sign. So let's look at another one. Let's take 4 plus -5. So I'll come over to 4. 1, 2, 3, 4. And I'm adding -5, so I move to the left. Change colors here so I can overlap. 1, 2, 3, 4, 5. And I end up on -1. Well, if I take the absolute values and subtract from the bigger absolute value the smaller, this would give me 1. But I keep the sign of the bigger one. And in this case, I kept the sign of the bigger one. So if we're adding two numbers and the signs are different, you subtract the absolute value of the smaller number, smaller absolute value, from the larger absolute value. And then in the answer, gets the sign that was on the larger number. Running out of space on the side there, but we can see what we get there. And so we can simplify additions to subtractions when the numbers are different, when the signs of the numbers are different. And let's get a little more space down here. Let's look at some of these. So if I have 8 plus negative 13, well, that's way too big of a number line to draw. So I'll look, this is my bigger number. So I'll take the absolute value of negative 13, and I'll subtract from it the absolute value of 8. And I get 5. 13 minus 8 is 5. But my bigger number was negative, so this is negative 5. A neat property of numbers is shown by the opposites. If I add an opposite to a number, I get 0. And this has to do with how they're balanced on the number line. If I start at this number and move in the direction, well, the distance from the 0 is the same for both of these. So by going the opposite, it pulls me back to 0. And so if you ever see two opposites together, they bring you back to 0. Now, because we can stack additions up, that we can get multiple additions, what you want to do when working with these, let me get some more space here, clear this out. Is if you have multiple additions, well, addition is commutative, so we can switch the order any way we want. And so I could do the 5 plus 3 first and get 8. I can do the 5 plus negative 9 and do the 3 plus negative 9. We tend to go left to right, so I would look at what happens with the first two. And so if I figure out what's happening with the first two here, I have negative 9 is my larger number. 5 is my smaller number in absolute value. So I would get 4, but my sign is negative. So those two would become negative 4 plus 3. And then I'm going to have the absolute value of my larger number minus the absolute value of my smaller number, which is 1. But the sign of my larger number was negative, and so this is negative 1. So when you have multiple additions coming across, do them in pairs and try to write each step as you work your way through. So once I've done these two numbers, that becomes a new number for me. And I'm left with this smaller addition. It's good to do the pieces step by step so you have a way to go back and forth. It's easy to switch signs around when doing these types of things. So if you leave your steps behind, you can find what's called sign errors. Well, we can do variable substitution with the idea of negative numbers. So if I have a variable expression, and I'm going to say that my x is equal to 2, and my y is equal to negative 6, I can substitute these in. Now when I substitute in for variables, I leave parentheses so I can keep track of the signs, and so I can keep track of the different things coming in and out of them. And so I've now made this equal to this, and I'll do my multiplication here, and then I have a negative 6. Well, hey, I've got opposites, so this is 0. Because positive and negative numbers get used in measuring a lot, we can use this to talk about the difference or the meaning of things in scales. And a good example the book has is if we have a thermometer. Right. We have a thermometer, the old big dish type of one, or like the ones outside, and it's minus 5 degrees Celsius. So it's below freezing. Well, this is a scale, right? The mercury's here, and it's going to move as it heats up in the positive direction, and as it cools down, it falls below. And so integers are a good way of talking about this. And so if it's negative 5 degrees Celsius at 5 a.m., the sun comes out, and by 12 noon, the temperature has risen temperature has risen 9 degrees. We can talk about this rise as an addition. And so I can say negative 5 degrees Celsius plus 9 degrees Celsius. I'll keep my units here. And so I have different signs. So I take the absolute value of the bigger, and I subtract from it the absolute value of the smaller, and I get 4. And I'll keep the sign of the larger absolute value. And so the answer to this is 4 degrees Celsius. And it's a common use for us to use integers in measuring, but having an origin that we start from, that makes these things good for measuring.